Good morning, everyone. Today in this session, I will explain the factors affecting on bond length. Okay, the topic name is the factors affecting on bond length. Okay, so first we have to discuss the what is the bond length. Okay, so simple. This is one atom. This is one atom, and this is also one atom. Here is the middle nucleus is there. We know already. So there is a distance between the two nuclei. What is this? This is the distance between nuclei. So this is called the bond length. So we have to measure the length between two nuclei of the two atoms which are present in the molecule. That is called the bond length. So now, which factors are to affect on the bond length? So there is a factor 1. Bond order. First of all, that length. What is that length? Bond length. That is inversely proportional to bond order. Okay. So if maybe there is a bond order increases, automatically bond length will be decreases. So for example, I give the carbon triple bond and carbon double bond and carbon single bond. Okay. So we know that this is a bond order which is highest. The triple bond is the highest bond order, then the double bond and then the single bond. So automatically there is the bond length will go for the triple bond is less than compared to the double bond, and we know there is a single bond is excess bond length between the carbon and carbon. Okay, so I will give another example also. So that example is there is a nitrogen triple bond nitrogen, oxygen double bond oxygen, fluorine single bond fluorine. Okay, so here in this case, which has highest bond length? That's your question. So we know where this is a bond order. This is a bond order. So there is a triple bond, there is a double bond, there is a single bond. Automatically, so there is a bond length will be go for the. So which one is highest? Fluorine single bond. Then after oxygen. Then after nitrogen triple bond nitrogen. So this is a one factor. So that is the bond order. So there is bond order increases, then automatically bond length will be decreases. For the triple bond, there is a bond length is shorter compared to the single bond. So this bond length is a long. This is a shorter. So this triple bond is a shorter bond length and that single bond is a longer bond length. Okay, great. Next one, come to the second one. That is a atomic size. So I write the bond length directly proportional to atomic size. So atomic size increases, then after automatically bond length will be increases. So atomic size increase, there will be bond length increases. So I give you an example for that. This factor, how it is to depend for the bond length. So we know very well carbon and nitrogen, carbon and oxygen, carbon and fluorine. In the periodic table, so when from the left to right, there is a bond length will be decreases due to outermost shell of the electrons, which are to outermost shell electron, which are to enter into the inner orbital, outer shell electron. So that's why there is a carbon nitrogen and carbon oxygen and carbon fluorine. So automatically there is atomic number increases, but actually there is atomic number increases, so atomic size increase. But in the periodic table, from the left to right, atomic number is increases, but there is a atomic size will be decrease due to that outermost shell electron will be entering to the inner orbital. Okay, so now here is a carbon nitrogen, carbon oxygen. There is a bond length. So atomic size is this one is the highest than this one. So finally we go for the bond length, which is highest. Carbon single bond is the highest than the carbon fluorine due to there is a fluorine is atomic size is small then compared to the carbon, nitrogen and oxygen due to that outer electron will be coming to the inner orbital. Okay, right. Same, I will give the example CF, CL, CBr, and CI. In this case, also there is a CI, CF. We know very well from the top to bottom, in the periodic table, atomic size increases. So here is a atomic size and bond length both are directly proportional. So finally, we know very well that Ci is longer bond length. This is a shorter bond length. So due to atomic size. So iodine atomic size is excess than the fluorine. Okay, this is the case 2. Then I go for the case 3. Note down first. Okay, first of all, you write now. Right. Next one, I give the third one factor, that is the electronegativity. The third factor is electronegativity. So electronegativity and the bond length both are inversely proportional. If electronegativity increases, then automatically electronegativity increases, then automatically bond length will be decreases. So same question, that is a CC, CN, C oxygen, and C fluorine. So we know already the electronegativity, which is highest fluorine, and then after oxygen, then after nitrogen, then after carbon. Right? So here is the electronegativity is excess for the fluorine, then compared to the carbon. But here is a bond length compared to the carbon-carbon and carbon-fluorine. So carbon-carbon is the bond length is a longer than carbon-fluorine due to it's having the electronegativity excess. So then electronegativity increases, then automatically bond length decreases. So finally the bond length carbon-carbon, carbon-nitrogen, carbon-oxygen. So carbon-carbon is the excess then compared to the carbon-fluorine. Due to this electronegativity is less. Understood? Right. Same question we can apply here. CF and CCl, CBr, Ci. So we very well. So this is a fluorine electronegativity is excess. Chlorine, bromine, iodine. The electronegativity increase, then automatically there is a bond length will be decreases. So when it is to electronegativity increases and it can be to attract the electrons. When it is to attract the electrons, then the bond length will be to decrease. So here is a electronegativity is less. So attracting electrons capacity is less. So that's why there is a bond length will be increase. Okay. So finally Ci is increased, then Cbr, then CCl. Understood? So this is a electronegativity factor to depend on the, it can to effect on the bond length. Then go for the second. The fourth one. Fourth one is the hybridization. The fourth factor is hybridization. Hybridization in that percentage of S character. Okay, so how it is to affect on bond length, we discuss now. So we know that hybridization sp, sp2, sp3. There is in the percentage of S character. So here is the 50% S character. Here is a 33.33% S character. We know already, and 25% of sp3. Okay. If maybe there is S percentage increase, there is a bond length will be decrease. So the percentage of S character and bond length both are inversely proportional. So here is a excess of S percentage. So of this hybridization of element of that bond length is smaller compared to the which is to hybridization in the sp3. Bond length is excess. Okay. So come to the question. C triple bond C, C double bond C, C single bond C. Here is a of these carbon atoms. Here is a hybridization of that carbon sp, and this one carbon is under the sp3. This is a carbon under the sp2. Okay. So we know already there is a percentage of S character and a bond length both are inversely proportional. So finally we know very well there is a percentage of S character which is excess, sp, then sp2, then sp3. Okay. Percentage of S character order. So which has highest percentage of S character, they consist the bond length is very shorter than compared to the sp3. Okay, right. So now here is compared the bond length will be go for the sp3 hybridization which is present in the carbon, carbon. Okay, so now here is a carbon, carbon, sp hybridization is present. So understood? So I will give another example. Now here, carbon, carbon, triple bond and hydrogen, and carbon, double bond, carbon, hydrogen, carbon, single bond and hydrogen. So now you have to mention that there is a question number 2. So you now give the order bond length between the carbon and hydrogen, which is has excess. So we know that this is a hybridization of sp, this is sp2, this is of sp3. So here is the electronegativity is excess due to the percentage of s character. So we know that this one is the shorter bond length, this one is the longer bond length, okay, between the carbon and hydrogen. So finally we go for the sp3 hybridization is excess of bond length between the carbon and hydrogen. Okay, understood? Right. This is the 4th case. No, no. Okay. Right. Next, I will give the 5th case. That is a resonance. So how it is to affect on the bond length of that resonance. The 5th factor is the resonance. So in this case, delocalization is possible. Okay. Right. First, in this case, we have to remember that is a pure single bond is having the highest bond length. Okay. Then intermediate, that is the resonance. So compared to the pure double bond. It means if there is a pure double bond is there, it has a shorter bond length than compared to the resonance. Okay, I'll give you some examples. You can easily to understand. Right. So here, carbon and carbon, there is a single bond is present. Now I am giving the carbon-carbon single bond, and here is a carbon-carbon after double bond. Double, single, double is given. Now it is a carbon-carbon double bond. Your question is, in this, which has the longest bond length? Okay, right. We know already, compared to the carbon-carbon single bond is the excess bond length, then compared to the carbon-carbon double bond. So obviously this is the first, then compared to this one. But what about here is the carbon-carbon single bond here is also present, and compared to this one. Okay, so in this case, first of all, this is a pure single bond. Okay, there is no any pi bond, there is no any resonance. Okay, no resonance. So there is no conjugation, there is no resonance. But here is a conjugation is occurs. So there is a conjugate is present, then automatically resonance is there. But here is a no resonance. No resonance. But it is pure double bond. Pure double bond. Okay. So finally, pure single bond is having the bond length is excess. This is the bond length of order. Pure single bond is consists the excess. So compared to the carbon-carbon single bond and compared to the this carbon-carbon single bond, here is what happened. There is a carbon-carbon single bond. There is after delocalization, it will be getting the partial double bond. Okay. So once these electrons come to this side, and automatically these electrons come to positive charge side. Okay. There is a conjugation is possible. So by this conjugation, these of single bond partially getting the double bond. So that's why this of carbon-carbon single bond is the shorter than compared to the pure single bond. So there is no any resonance, there is no any conjugation is there in that component. That is the excess of bond length is consist. But here is a conjugation is possible because of double, single, double is there. So there is a moving of electron from this double bond to single bond. In that case, this single bond is getting the partial double bond. Okay, so that's why it is shorter than the pure single bond. This is a shorter bond than pure single bond. And what about the pure double bond? So here is a double bond is there, but partially this double bond is getting the single bond also by the resonance. So compared to the double bond, pure double bond, there is a double bond becomes to again single bond, and here is a single bond getting the double bond. So that's why there is a pure double bond is a very shorter than compared to the resonance. Okay, so these intermediates of resonance is a shorter than pure, longer than pure double bond. This is a pure single bond, this is a pure double bond, this is a shorter. Okay, so finally we go for the pure single bond. Is a bond length is excess. Okay, here is a partial double bond is forming between these two carbon atoms, which is present in their single bond. Okay, but here is a pure double bond is there. There is no any resonance. There is a fixed double bond is there. Right. So this is the resonance. How it is to affect on the bond length. So this is the intermediate compared to the pure double bond, and this is shorter than the pure single bond. So you have to remember this case. So I will give you more example in the next session in the MCQ. Okay, right. So note down this is right. I will give the next one. That factor is the oxidation number. The second next case, that is the sixth one, oxidation state. Sixth case, oxidation number of central atom. So oxidation number of central atom and bond length both are inversely proportional. If higher the oxidation number, means excess, there is maybe excess of oxidation number, but it consists shorter bond length, which is oxidation number is more, of that bond length is a shorter, because these two are inversely proportional. So I'll give you an example. Now there is a SO2 and SO3. Now you have to compare the bond length between the sulfur and oxygen, which has highest bond length. So first of all, you find out the oxidation state of the two examples. There is a option 1, option 2 there. So you have to find out the bond length which has highest. So first of all, we calculate the oxidation number. Then after, we get in the bond length which is have highest. So how we came to find out? We know very well sulfur, that is a central atom, and it is a oxygen. So many is there? 2. What about the oxidation state? Here is I mentioned the oxidation state of oxygen in oxide -2. If maybe in peroxide oxidation state, oxidation number -1. But here is a sulfur dioxide, sulfur trioxide, oxide is there now, so we have to take the -2. In oxide, oxidation state is the -2, you have to mention. Understood? So keep in mind these 2 points. Right. So sulfur dioxide in that oxygen oxidation state -2, that is equal to 0. And here is a sulfur trioxide sulfur is a central atom. How many oxygen? 3. So what about oxidation number? -2, that is equal to 0. So here is a 2 oxygens to multiply the -2, so -4, that is equal to 0. And after plus into -4, that is equal to 0. And yes, -4 is come to the out of the equal. There is minus will be goes to the plus 4. And now here is a coming to the 3 to the 6. So -6, that is equal to 0. And plus into minus, so -6. And once it is to come the outside the equal to, there is a s, that is equal to plus 6. So finally, you calculated oxidation state in both example. So which has highest, sulfur trioxide is the highest oxidation number, that is the value 6. In that sulfur dioxide, there is a plus 4. So sulfur dioxide. But what about bond length? Very good. Bond length, already I mentioned here, oxidation number and bond length both are inversely proportional. So which has highest bond length, which has highest oxidation number, of that bond length of sulfur and oxygen is shorter. So the bond length is having sulfur dioxide excess, then sulfur trioxide. Understood? This is a one type of case. That factor, oxidation number of that central atom, and it may be too higher, bond length will be shorter. So this one is a shorter bond length. Shorter bond length. This one is a long bond length. Longer bond length. Understood? Right. So this is sixth case. I will give the seventh case. Repulsions between the lone pairs. Right. Seventh one is the repulsions between lone pair of electrons. So if there is excess of lone pair of electrons, excess of repulsions, and there is a closer the bonds, means finally there is a repulsions is excess between the lone pair of electrons, and automatically bond length will be decreases. So you keep it in mind. So I will give you an example here. Nitrogen, there is a lone pair 1, hydrogen, hydrogen, and hydrogen. This is ammonia, and here is the oxygen, and here is present of lone pair of electrons, lone pair of electrons. So here is the excess, matlab higher the repulsions, higher repulsions. Higher repulsions means closer the bonds, closer bonds. So which there is the, if maybe there is a higher repulsions between the lone pair of electrons, there is a closer the bonds. Matlab there is oxygen hydrogen bonds very shorter because of repulsions of lone pair of electrons. Higher repulsions between lone pair electrons. So higher means repulsions excess. There is maybe atoms of bonds, bond atoms closer bonds. Okay. So now here is a less repulsions. So there is another lone pair of electron is not present. Only the single lone pair of electron is there. So there is repulsions is less repulsions. So finally, compared to the water and ammonia, we know already 107 is its bond angle, and for this bond angle for the water 104 degrees. We know very well. So here is bond length is increases, no? Right. So finally, the repulsions of lone pair of electrons increases of this oxygen and hydrogen, and of this nitrogen and hydrogen bond length are compared. The bond length of nitrogen and hydrogen is longer than compared to the oxygen and hydrogen. Okay. So because of there is a lone pair repulsions, when they are involved in the repulsion, these bonds are very coming to the closer with each other. And now in this case, there is a lesser repulsions because of there is only one repulsion, another one lone pair is not there now. So that's why there is a lesser than compared to the second one. So of this nitrogen and hydrogen bond, and of this oxygen and hydrogen bond, compared to the nitrogen and hydrogen bond is longer than the oxygen and hydrogen bond due to the repulsions. Understood? So these 7 factors mainly affect on the bond length. So remember once, first factor is a bond order. Bond order and bond length both are inversely proportional. And second one is atomic size. Atomic size and the bond length both are directly proportional. And the third one, electronegativity. Electronegativity and bond length inversely proportional. And fourth case, hybridization. Percentage of S character inversely proportional to bond length. And fifth case there is a resonance. Resonance in that delocalization. So pure single bond is a excess bond length then compared to the resonated structures. So resonated structures are intermediates. Okay, pure is the first, then intermediates of that examples of resonance. Then after pure double bond is very shorter. So keep it in mind. So the next one factor is the oxidation number. Oxidation number and bond length both are inversely proportional. Okay, right. So we have to calculate first central atom of oxidation number. If maybe there is oxidation number excess of that component considers the bond length decrease. So shorter. And come to the repulsions between the lone pair of electrons. If there is a lone pair of electrons excess in their molecule, their atoms or bonds are very closer to them. And next one, which has a lesser lone pair of electrons, there is a atoms of that bonds there is a longer. So finally, the less repulsions between the lone pair of electrons, there is a bond lengths are excess, and there is a lone pair of electrons is repulsions is forming is excess, there is a shorter the bond length. So that is the very important. So this is the factors affecting on the bond length. So I will give you some more examples, and we can be practice a MCQ also in the next session. Okay, keep it in mind. Follow my channel. Okay, right.